This video describes the procedure to model the holder for which the multi-views are shown on the screen. Front and the right side view have been provided. By looking at the various faces that exist on these two multi-views, we need to interpret the features that are generated from this. So to begin with, we'll start with one of the views here. These are the two views which are being shown in SolidWorks. Let me turn on the shades. So as seen in the front view, the visible edges form faces which are being highlighted with different colors. There are 4 different faces that are seen in the front view. The same as when we look at in the right side, we have 2 different colors for the 2 faces, and there's one in here in the form of a circular shape. So these are 3 different surfaces that can be seen in here. So the circular shape can, once when interpreted, whether it is a hole or a solid boss, we can say it's a face or it's a hollow region. So let's try to pick up these from any of the 2 views. I'll start with the right side view. So we have got a surface here in the color green. If I pick up this, it corresponds to the line as shown in here. I'll remove the colors in the front view. So when I pick up the face here, it's highlighted with blue color line over here, representing a curve as a curved line in the front view. So the entire surface that we see as a blue, the region selected here in the right side view, lies on this curved surface. The next one below is the red surface. When I pick up this, I find that it gets highlighted onto the vertical edge coming on the right face of the front view. So the whole shape as shown in here lies or is appearing as an edge in the front view. So this is how we try to visualize the various features, by looking at the surfaces and then their corresponding sketches in the other views. So we have 2 of these already identified from the side view. The third one that we have for the circular and sketch entity here, as we project lines, we find that it runs through from the curved surface over here. So a portion of it lies on the curved surface, the rest is on the planar surface that we have here. So as it runs through the surface, it goes all the way till the end, drilling a hole as indicated by these 2 hidden lines. So it's basically a hole, and for which we see the true shape of the circle in the right side view. So this is all about what we have from the right side. I'm not going into the features that are being shown by the hidden lines. We'll come that to a little later. So these are some of the details which are shown by hidden lines. Now coming to the faces that we have in the front view, if I change this to a display style with the colors there for the closed contours that lie on here. So we have got a color on the top here. If you project construction lines or projection lines from the top and bottom of this, it corresponds to the small vertical step that is shown in here with a height of 6. So the whole surface here is said to be a normal surface, and we see the true shape of the face that is shown in here in the front. The second face that we have here, when I pick up this, it corresponds, the top and the bottom of these contours, they correspond to the inclined line here at 30 degrees to the vertical. So what we see here is a foreshortened size of the shape that would lie on this inclined edge that is shown in here. Lastly, we have second last, we have got a surface here and projected onto the right side. It corresponds to the height of 10, the vertical edge that we see. This is the frontalmost surface on the part. The other 2 surfaces that we have seen here, they lie slightly far behind the front surface. This is the frontmost surface and is having a height of 10. The last one at the bottom here, when I pick up this surface, I can see a vertical edge being highlighted with dimension 6. So this is slightly offset inside by a distance of 14 from the front edge, but it's still a normal surface. We are looking at the true shape of the surface that we look at from the bottom side. This is actually the front face that we are looking at to get these different shapes. With that done, let's try to look at the internal features that come in here. So I'll switch back to the other view that we had. Now we have some of these details like if you look at the leader line here, it says 2 by 5 10 and a depth of 19. So there are two cylindrical holes, each having a diameter 10 and the rest and a depth of 19. So the positions are located in the front view with the center lines as shown here, center to center distance, and the first one starting at a distance 13 from the left edge, and when seen from the right side, it starts from the back of the part by a depth of 14. So this is the position for the center of the two holes. We have another hidden line coming here in the side view. So this is the horizontal hidden line. When projected onto the other side, it actually comes from the intersection of the two faces here formed by the two vertical and the horizontal line here. So this corner here, when extended deep inside, is hidden when seen from the right side. We have already covered these two hidden lines here. They correspond to the hole that is being drilled from the right face with the circle here, which is having a diameter 15.8 to 15.88 as the limits. So this completes the visualization or interpretation of the view part. Let's try to see the modeling approach in SolidWorks. When it comes to the making of model in SolidWorks, either you can start from the front or the right. In this case, we can begin with the right side. I would prefer starting with the right side, making a closed contour for the overall shape of this part, extrude it completely, and then trim out the extra regions that we have here to get to the final shape. This is the top to bottom approach that would be adopted in SolidWorks. Assigning the dimensions here for the auto contour that has been made. This is a width of 54, height of 57, step here for 27, 14, height of 6 for the small step, .30 as the angle between the vertical line and the inclined edge, .6, and now that's a fully defined sketch. Let's extrude this completely over the entire length of the part. This is 114, and reversing the direction to be in the other side. So thus this becomes the right face. So we have completed all the contours that appear from the right side on the as an overall block. Let's try to trim out the extra material here to generate the internal faces or generate the separate faces that come or that are seen from the right side. So the true shape of which is being shown in the front. So I would pick up the frontal plane, and you can even select any of these faces which are parallel to the front to make a sketch on it. Going normal to this, and I would sketch a arc. Make sure you do not drop it onto the midpoint here. It gets constrained, so leave it coincident with the right edge. Let it get defined with the radius. There's another slot that we can cut out simultaneously, as can be seen here that the cut that we see for the radius 60 and the slot here, rectangular slot with a size 6 and 25, they have through all cut or have a complete depth as that of the part, so we can cut them together in one single step. I would make a rectangle here, and while we make two contours to cut simultaneously in one single step, it should be closed contours. So I would close these, the first one here by adding horizontal and vertical lines on the edges here to form a closed contour for the arc. This has a radius 60. Okay, at the same time, there is a relation here between the center for this with the origin as vertical, or the right edge. You can pick up the right edge. We have one of the distance provided here as 57 from the far end. And for the other one has 6 and 25. Okay, let's cut them together. This is going to be a through all hole. Okay, the contours to be selected. We have more than one contour here, so I'll identify the contours that are to be cut through. It's always better to have this in the form of isometric or diametric view before we actually make a cut, to look at the direction in which it cuts through. It is cutting the part from in the back direction. It has to be reversed. Okay, that generates the two faces, the true shape which is being seen from the frontal side, for the faces being generated on the right face. So this is one face that we see from the right side. This is another one that we have looked at. There's a hole which runs through this, so I'll pick up the right face and make that a sketch plane, sketching a circle onto it. The center lies on the top edge here, and it is positioned to the left edge here with a spacing of 17, having its own diameter as a limit dimension 15.82. Let's add the limit. We have to add 0.06 millimeter to make it 15.88. Cut this through. With this done, we now try to make all the features that are being seen from the front side. We have the first surface, this is the second surface in the front, this is the third. We have also the one being seen at the bottom here, this is the fourth one. We see all the visible surfaces already appearing on the part, so let's try to add the internal features. There were two holes coming in from the top face here. We make use of Hole Wizard for that. They are blind holes with a conical tip at the bottom, so it's the third type here, the hole. The standard is asymmetric, and the hole size, it's a 10, so it's available under dowel holes, or you can even check the box for custom sizing and specify your own size. Since it's a standard size, I pick it up from here under the size and the condition. In condition, make sure you put it as blind and specify the depth as 19. And we move on to the next tab, which is positions, and select the top face from where we would like to drill this hole. So this is the top face, and drop two holes. And before we accept this, let us define this, going normal to this and giving some dimensions between them as 25 center to center distance. We have 13 from the left edge here to the first hole center. We have the depth from the back end as 14. and a relation of horizontal between the two centers. Okay, that's now a fully defined sketch. Let us try to accept this to have those two holes drilled in the part. Now if you would like to check if we have come up with all the features that are in here, we can split this into two vertical views, the whole screen, and then turn on the hidden lines as the display for both the views. Compare it with the given question. So this is basically all what we had in the question. So that covers all the features from this particular part. So with this we come to the end of this particular exercise.